Assalamualaikum. Hi guys. Let's continue with our last subtopic for this chapter, which is factors affecting reaction rate. In this video, we are going to learn how to explain the effects of these following factors based on the reaction rate. And we should know how to illustrate the effect of temperature on reaction rate by using Maxwell-Boltzmann distribution curve. And you also need to know how to compare the curve of energy profile diagram for a reaction with or without catalyst. Let's go one by one. So there are several factors affecting the rate of chemical reactions. What we are going to discuss only 4 of them. The first one is concentration or pressure. The second one is temperature. The third one is particle size. And the last one is catalyst. Let's go with the concentration first. So for concentration, contoh yang mudah untuk kita nampak, let's say saya ada room A and room B. In room A, we have 4 people. In room B, we have 100 people. So which one will be high tendency to get more collision? Of course, room B. Sebab ramai orang dekat dalam satu bilik yang saiznya sama berbanding dengan room A. So what can we say here? When you have high concentrations, it means that more collision between the molecules. So as the concentration of reactant increases, number of particles per unit volume increases. Sebab tu saya guna contoh room like this one. Therefore, frequency of collision increases. Kita baru cakap pasal frequency of collision. But you should include the third point, number of effective collision also increases. Kerana hanya effective collision sahaja yang akan menghasilkan produk. Thus, the reaction rate increases. So kalau lihat perbandingan antara rate law, what we've discussed already, reaction rate di mana we have the rate law just like this expression, and X and Y adalah reaction order. So berdasarkan equation ini, kita boleh lihat reaction rate is directly proportional to the concentration of the reactant. So maknanya kalau reactant awak banyak, so it means that when you have higher concentration of reactants, it means that reaction rate will be increased. One reminder for you, only zero order reaction sahaja reaction rate dia independent of the concentration of the reactant. So tak kisah kalau awak ubah pun number of concentration, dia tak akan jadi apa-apa, nilainya hanya sama, constant. Let's go for pressure pula. So pressure only applies for the chemical reaction involving gas only. So effect for changing the pressure is similar to the changing the concentration of reactant. So bila awak increase the pressure, volume akan berkurang. So number of gas particle per unit volume tu akan bertambah apabila awak increase the pressure. Therefore, frequency of collision increases, number of effective collision increases, hence reaction rate also increase. For particle size, kebiasaannya kita akan lihat untuk heterogeneous mixture. Let's say we have this reaction, magnesium reacts with HCl. Magnesium ini adalah metal, that's why we have it in solid phase. So usually for particle size, bahagian pelanggaran di sebelah tepi ni akan berlanggar dengan molekul yang warna merah. Tetapi yang dekat tengah ni tidak akan terlibat dalam pelanggaran. So in order for us to involve this area in the middle, we are going to make it this molecule splitted into smaller bits. That's why pelanggaran tu akan jadi lebih efektif. So the smaller the size of reacting particles, maknanya particles itu akan mempunyai greater total surface area exposed for the reaction. Hence, collision akan berlaku. That's why the reaction becomes more faster. So in heterogeneous system, area of contact between reacting substance ni akan mempengaruhi reaction rate. That's why awak akan kecilkan dia macam this one instead of one whole lump like this one. And then for reactant in solid state, solid particles ni dia immobile dan dia rely on liquid or gas particles yang collide with solid surface to react. Maknanya, dia tak akan bergerak tapi dia bergantung dengan pelanggaran daripada liquid or gas particle sekeliling dia. So, sekiranya kita break the solid into smaller pieces, total surface area tu akan makin besar. Sebab tu akan ada banyak pelanggaran, more collisions. So, let's say we have one example. I have a meat, saya ada seketul daging. Saya nak fry daging ni atas satu frying pan. It is more easier for me to cut the meat into smaller pieces so that saya boleh increase the total surface area dan reaction saya lagi cepat berlaku dan daging tu lagi cepat untuk masak. So same case macam this one. So apa yang kita boleh conclude when we want to write the final answer, the smaller the particle size, surface area increases, frequency of collision increases, number of effective collision also increases, rate of reaction increases. So itu adalah cara kita nak faham tentang particle size. Let's go for catalyst. So catalyst is a substance that increase the reaction rate dengan cara dia provide alternative pathway with a lower activation energy. So macam mana catalyst ni berlaku dalam reaction? Dia akan kurangkan peak of energy level. Contohnya ini energy profile diagram. Saya ada reaction with catalyst warna merah dan reaction without catalyst warna biru. So boleh nampak activation energy for the one with red color is lower compared to the blue one. So ini function catalyst, dia akan lower the activation energy. However, catalyst will not affect the enthalpy for reactant or product. Dia hanya kurangkan activation energy sahaja. Enthalpy untuk reactant dan juga produk kekal sama. Untuk activation energy, saya repeat balik, ini adalah konsep yang kita dah belajar dalam video sebelum ni. Activation energy is the minimum energy required to convert reactants to product. So itu adalah definition for activation energy. So cara yang terbaik untuk kita explain tentang catalyst, when catalyst is added to the reaction, the new alternative pathway with a lower activation energy is produced. So more particles can overcome the new lower activation energy. Therefore, number of particles that have higher energy than activation energy increases. So frequency of effective collision increases, reaction rate also increase. So bila awak jawab, pastikan awak jawab dalam bentuk bullet point, bukan essay. It is more easier for examiner untuk tanda your answer. Next, we go for the next factor. Ini adalah faktor yang terakhir, iaitu temperature. Bila we talk about temperature, we are going to relate with kinetic energy for the reacting molecules. So, macam mana kinetic energy tu boleh produce? When you increase the temperature, the average kinetic energy for reacting particles also increase. Jadi, number of molecules with energy equals ataupun higher than activation energy juga akan bertambah. Jadi, frequency of collision bertambah. Therefore, number of effective collision increases, reaction rate also increase. So, sebab tu dalam jawapan awak, when you write the factor about temperature, you have to relate with kinetic energy as well. Dan pastikan number of molecules with energy, dia perlu ada kinetic energy more than ataupun equal than activation energy. Barulah dia boleh hasilkan more higher number of effective collision. So, untuk Maxwell-Boltzmann distribution curve, kita belajar bahagian this curve under factor temperature, di mana this curve analyse the behaviour of gas molecules at different temperature. Let's say saya ada this graph, saya plot curve untuk Maxwell-Boltzmann distribution curve. Awak kena tahu how to plot this curve sebab biasanya dia akan minta awak untuk draw. So we have number of molecules sebagai y-axis, kinetic energy sebagai x-axis. So apabila awak ada dua different temperature, saya akan draw satu graph like this one dan saya label dia sebagai lower temperature. And satu lagi saya akan label sebagai this one, high temperature. So apabila awak ada dua curve macam this one, bahagian di mana curve ini hampir bertemu ataupun sama dia punya kinetic energy, saya akan label sebagai activation energy, EA. So itu adalah apa yang awak perlu label dalam bahagian distribution curve awak. Seterusnya, awak kena label juga shade of area under the curve. So cara dia macam mana? Kita akan shade the area under the curve like this one. So area under the curve ni bermaksud total number of molecules in the reaction. Dan total number of particles under each curve adalah sama. Tapi kalau awak compare yang biru dengan pink, awak boleh nampak the pink colour got more number of molecules compared to the blue one. Because the pink colour got higher temperature. So bila higher temperature, more kinetic energy. That's why more number of particles can collide with one another. This is because more molecules ada high kinetic energy due to the high temperature. So mari kita discuss more. Let's say saya bagi two values for two different temperatures. You can see that T1 is 200K and T2 is 500K. So 500 Kelvin is higher temperature compared to 200 Kelvin. So awak kena tahu cara lukis distribution curve ni. Biasanya kita akan mulakan dengan low temperature, dia ada high peak. High temperature, dia ada low peak. Dan pastikan awak shade the area dan label EA. So apa yang kita boleh describe daripada this curve, the shaded area represent the number of molecules that have the kinetic energy more than activation energy. So maknanya molekul ini sudah boleh overcome the barrier. So bila dia boleh overcome the barrier due to higher kinetic energy, maknanya frequency of collision akan makin bertambah. So number of effective collision also increase. That's why the reaction rate also increase. Let's try one example for these factors. So saya ada iodation of acetone with rate adalah this one. And then the equation is given. It asks you to suggest two ways how we can increase the rate of reaction. So untuk this answer, awak kena explain sedikit lah sebab dia minta awak suggest two ways. Even though we've learned so many factors that can affect the reaction rate, hanya dua sahaja jawapan yang logik untuk kita terima bagi soalan ini. First thing first, sila lihat unit untuk rate awak. So unit untuk rate adalah molar per second. So molar per second adalah unit untuk zero order. Hence, bila zero order, kita kena lihat juga apa yang terjadi. So bila zero order dia tak dependent kepada concentration. Sekiranya awak ubah nilai dia tetap sama. So that's why kalau kita kata increase the concentration, there will be no effect. So concentration tidak boleh dijadikan sebagai cara untuk increase the rate of reaction. Next, untuk particle size. Untuk particle size, kalau lihat dekat sini kita ada phase aqueous sahaja. Okay. Particle size usually applied for solid. Jadi, reaction ini in aqueous phase, there will be no effect bila awak increase particle size. Next one, kalau saya nak guna pressure. Pressure only apply for gas. Sedangkan reaction ini dalam aqueous. So same case juga, no effect when you increase the pressure. Because this reaction is in aqueous phase. So apakah faktor yang boleh diterima? Hanya dua sahaja faktor, iaitu yang pertama, you increase the temperature. So bila you increase the temperature, kinetic energy bertambah, frequency of collision bertambah, frequency of effective collision also bertambah, therefore reaction rate bertambah. Satu lagi cara adalah you add the catalyst. So addition of catalyst akan lower the activation energy, therefore more molecules will possess kinetic energy greater than activation energy. So frequency of effective collision also increase, reaction rate also increase. So kalau nampak jawapan saya dah buat dalam bentuk paragraph. Tapi boleh juga kalau awak nak guna dalam bullet point, it is more easier for examiner to tanda your answer. Tapi untuk saya dalam kes ini, saya nak jimat space, I did it in a simple paragraph. So far kita dah belajar banyak factors that can affect the reaction rate. Kita ada effect of concentration, apply for gas and aqueous phase only. Effect of pressure only for gas. Effect of temperature, awak kena tahu draw the Maxwell-Boltzmann distribution curve. And then effect of particle size hanya untuk solid. Then effect of catalyst, macam mana awak ada catalyst with or without catalyst for the reaction. How the catalyst can affect the reaction rate for your chemical reaction. So sampai situ sahaja for our video today. I will see you in the next one. Bye!